I'm here with the predictions for paper 2 of the A Math paper. Hi everyone, Mr. Wong from Genius Plus Academy here. I'm here with the predictions for paper 2 of the A Math paper. I hope the paper 1 was kind to you. I personally thought that paper 1 was a relatively straightforward paper, so I would expect the paper 2 to be slightly tougher, similar in nature to what happened in 2020, where the paper 1 was relatively easy, but the paper 2 was relatively difficult. So best to be prepared for it. Now, in terms of the predictions, the parts in red are the parts that were tested in paper 1. So for A Math, quite straightforward. Generally, they test more than 95% of the syllabus. So anything that has not been tested in paper 1 would likely come out in paper 2. All right, I've taken down the question numbers as well to show you which are the various questions that tested which particular portions. Okay, so you can see that there are certain topics where there are clear blanks. So those are the topics that you would likely have to focus on for your revision for paper 2. Now, let's start off from the top. I would expect them to test a question involving conditions for when a quadratic has solutions and the number of solutions. This can be in general form, or this can be in relation to an equation involving the drawing of curves. So a straight line intersects a curve at how many points? All right, so if it's 2 points, then you should know what it means. If it's at 1 point, you should know what it means. If there is no intersection, what does it mean? They may ask you in reverse. So they ask you to show whether it has X number of solutions, 2, 1, or 0. So instead of telling you directly to show that, they may ask you in reverse. Okay. Also, make sure you know how to apply your discriminant. And more importantly, when you are solving quadratic inequalities in order to determine what the value of certain unknowns is, pay attention to the range of acceptable values, right? If it's a positive quadratic U shape, that is what gives it always positive. And if it's a negative quadratic, then N shape, always negative. You have to pay close attention to the range of acceptable values, because if I ask you show that it's always positive, your value of the unknown, if there is an ax square, your a cannot be negative, because if your a is negative, then it's going to be N shape. It will never be always positive. Right? So those are the kind of tricky questions that you need to make sure you take note of. Other than that, pretty standard use of discriminants. All right, make sure you don't make any mistakes when you're solving the quadratic inequality. Always make sure you sketch out the diagram so that you can see which part of the quadratic inequality you want. Is it the part above 0 or is it the part below 0? I don't expect them to test certs anymore because you already have a 7-mark question on certs. But having said that, bear in mind that when it comes to certs, your special angle in your trigonometric functions, the answers need to be expressed in terms of certs. So they can test you certs in relation to special angles still, which was what they tested for the past 2 years anyway. Okay. For polynomials and partial fractions, take note your use of factor and remainder theorems to make sure that you know how to solve for unknown values in the equation using remainder and or factor theorem. Okay, but make sure you know how to factorize your polynomials. Make sure you know how to solve your cubic equations. I don't think they are going to test you your cubic functions. But again, make sure you do know them just in case. Binomial was tested in terms of the general formula, but there was nothing about binomial expansion using the theorem. So I would pay attention to this. Not very likely that they would test binomial in both paper 1 and paper 2, but I would pay attention to this just in case. So make sure you know how to do your binomial expansion using the formula that's given in your formula sheet. You can see that the entire log / indices part is totally blank, which means that you can be sure that they will definitely test it. Make sure you know the general shapes of the graphs, very important. Make sure you know all your laws of logarithms. They will definitely be testing that. Make sure you know your initial form with your logarithmic form. Make sure you know how to do change of bases. What is likely to be tested, number 1, is you will have some sort of exponential or logarithmic function that you are expected to solve. Number 2, you will likely have some sort of an exponential or logarithmic function as a model in a real-world application with linear log. That will be my prediction. So make sure you know all your laws of logarithms, but also make sure you know, I don't think they will test you about the general shapes of different types of logarithmic or exponential graphs, but just in case, you ought to know the general shapes. All right, I think this is more likely to be equation solving and also use of it in linear log to model, what they like to model, like population, or model like earthquakes and whatnot, or pH values. Hope chemistry did not traumatize you. Now, for trigo, principal values were not tested, but I don't expect them to test principal values. Just make sure you know them. Okay? For exact values of trigo functions, that is something that you should expect to see. Make sure you know them in both degree form and in radian form. Very important. All right. Normally in AMAth, they normally test it in radian form anyway, not degree form, but make sure you know for both. All right. You will see that in trigo, only your addition formula was tested in the form of tangent in question 3. So make sure you know this entire bunch of all your other identities. Make sure you know your double angle formula and its applications. All right, specifically, make sure you know how to do double angle formula, etc. by substitution. And then from there, know how to solve simple trigonometric equations within the given interval. In any given interval, please pay attention to the range. So if x is between 0 to 180, 2x is between 0 to 360, 4x is between 0 to 540, and so on. There was no proving of trigo identities at all, so expect them to test proving or trigo identities. For coordinate geometry, expect them to test circles, obviously, involving and including things like whether a point or a line touches the circle, or it lies outside the circle, or it lies inside the circle. Okay, make sure you know what those applications are. Expect them to test area of figures using your shoelace. Expect them to test condition for whether lines are parallel or perpendicular. It has kind of been tested, actually. You would consider this to have been tested specifically, right? But not the parallel part yet. Perpendicular part, because they tested normals, right? Expect them to test parallel, probably, but in terms of what? I would expect them to test it if they were to test it in terms of similar triangles. For your circles, please make sure you know both formula and how to complete the square to find your radius and your center of circle. I said just now already, expect them to test you linear law involving exponential and log equations. All right, make sure you understand for such things what the gradient represents and what your y-intercept represents, and how to find the values of certain unknowns within the expression by using logarithms. For proofs in plane geometry, even though it has been tested, the part that was tested was interestingly more EMAth than AMAth. Okay, there was actually no AMAth application really required for that particular question. So I would expect them to test parallel lines in special quadrilaterals, congruent or similar triangles, midpoint theorem, tangent chord theorem. Okay, so normally a figure involving circles such that you can apply your tangent chord theorem or your midpoint theorem, or figures involving triangles such that you can employ similar triangles and your midpoint theorem. Okay, so that is what I would expect them to test. And lastly, differentiation and integration. You can see that quite a fair bit has come out, but the parts that have not come out are fairly obvious. None of your trigo and your ln or natural number differentiation integration have been tested. So you need to make sure you know both the integration and the differentiation of all your trigo functions and your natural number or ln functions. Product and quotient rule was not required in paper 1. So expect them to test you expressions that require you to apply your product and quotient rule. They did not test increasing, decreasing function. So expect questions involving whether the expression is always increasing or always decreasing, or for what range of values the expression is increasing or decreasing. Make sure for this you understand that if you have perfect square or any even powers, it is always more than 0. So that is by deduction one of the ways in which you show that something is always increasing or something is always decreasing if there's a negative in front of the perfect square. All right, so make sure you know how to justify it and explain it by deduction. Again, differentiation of your sine and cosine functions and your natural number functions. Please make sure you know them. I will expect the last question in your paper to be everybody's favorite, involving kinematics. So remember the relationship between displacement, velocity, and acceleration. For such questions, take note that when v equals to 0, object changes direction generally. All right, so please make sure you sketch out the diagram to show the movement of the particle. Because if you directly substitute into your equation, you are not going to get the correct answer, because when the object turns, it moves in the opposite direction. Your displacement was increasing and then suddenly it will start decreasing again. But obviously, if you are finding distance, which is what the question normally will ask you to find, distance is not the same as your displacement. So you have to draw out the path of the object to see where the object is traveling and add up the distances traveled by the object. All right, so that is the main problem that students have when it comes to kinematics application. All right, so these are what I predict will come out for your paper 2. The parts in yellow, make sure you pay attention to them. But the parts that are not highlighted doesn't mean that they cannot be tested. So you are still expected to know them. But the parts in yellow are the main areas that you need to make sure you focus on. All right, so that's all I have for all of you. All the best for your paper 2 on Monday. Bye.